Hello everyone, I hope you're doing okay, and we're coming to the end of the course, chapter 11, and this is about probabilities. Probabilities have always interested me. They're kind of fun to look at. I've liked math since I was about 8 years old, and so this is an application of much of that. Lots of probabilities in the air lately. As we speak, just to warm up before I get to the actual exercises, the United States right now, or actually a few hours ago, no doubt the number has gone up, there were 1,174,202 cases of COVID-19, coronavirus, okay? So we passed the million mark more than a week ago. Of those 1,174,202 cases, 68,000, that's in the United States, 68,088 people have died. And that would mean that that number goes into that number 17 times. So one of every 17.2 people who gets the disease dies. So if you wanted to express that as it's about 6%. If you contract the virus, it's 1 out of 17 is about 6%. What's interesting to me about that, first of all, that number started out when we first started tracking these numbers in March. About 1 to 1.5% of the people who had the virus died. So that rate of 1.1 to 1.5% has about quadrupled since. Now you're 1 out of 16. If you get it, you'll die. And also you can compare numbers. This is more than the number of people who died in Vietnam. That was about 55,000. So this is going to go up to 70,000 by the weekend, probably, by the middle of the week rather. There's also a bit of fudging statistics about the tests that have come out. As of May 1st, the United States has tested between 5.59 million and 5.7 million, which is about, of the population, which is about 1/60th of the people in the country. We have a nation of about 325 million, so we've tested about 1 out of every 60 people. Yet what comes out of the White House is that we've tested more than all other nations combined, and then they list these nations. The nations they don't list, Italy, Germany, and Russia, 3 very large nations, those 3 combined have more than 7 million people been tested. So this is just a fallacy of repressed evidence. Suppressed evidence, you remember that, where you mention some details, but you don't include them all. You include just those that make your case. The testing has been very poor. 1 out of 60 people. We're a first world country. We've only tested roughly 1 out of 1.5% of all the people in the population. That's inexcusable. So, in any case, if you go to the exercises here on chapter 11.1, what is the probability of rolling a 5 on a single roll of a die? Well, a die has 6 sides, so the answer to that one is 1 out of 6. Okay, and so that's what you need to do there. What is the probability? Fine, and we'll get to probability formulas in a moment. The second one, from a sample size of 9,750 Ajax trucks, 273 developed transmission problems within the first 2 weeks of operation. What is the probability that an Ajax truck will develop transmission problems? Well, that number, the number 273, is around 140, if you'll notice, of the other. And in fact, it's so the chances that a truck will have transmission problems is about 0.28. Okay. That is to say, 1 out of every, what is the probability? 0.28. Now the probability in this case, how does the probability work? The probability, the formula, if you'll trace it back, the probability of any event A is equal to the favorable outcomes divided by the total number of outcomes. Okay, so the favorable outcomes, in this case, the favorable outcomes, it doesn't sound favorable, we're looking at the number of trucks that will have the transmission problems, divided by the total number there, which is 9,750, in order to determine the probability of that happening. And you get 0.28, okay? As far as the the third one here, the standard odds, and you see these kind of football odds and websites and so on. If the standard odds are 8 to 5 that the Chargers will beat the Lions, what is the probability that this event will occur? Well, okay, so the probability in this case is that, again, is 8 out of 13. Okay, so if it's 8 to 5, there's 13 possible outcomes and 8 are favorable. Okay, so 8 out of 13, and I think a percentage can be given here. It's about 0.615, a little more than 3 out of 5, right? 8 to 5 are the probabilities. That was number 4 has a star there. You can trace that one back. 5, what is the probability of picking a blackjack from a poker deck without jokers on a single draw? Well, he says without jokers, so that's a deck of cards is 52 cards, and there are how many blackjacks? Well, you would have a jack of clubs and a jack of spades, so total outcomes would be 52. Favorable outcomes would be 2, so 2 over 52 is 1 out of 26, of course. That's the probability there. If the probability of the Red Sox beating the Tigers is 6 out of 17, then what are the odds of the Red Sox beating the Tigers? Well, here, odds are expressed as favorable outcomes divided by unfavorable outcomes. So, so in this case, favorable is 6, unfavorable if there's 17 total, it means 11 are unfavorable. So the odds are, in this case, 6 out of 11. Okay? So that's the first 6. The number 7 here, or the number 7 has a star next to it. All right, let's do it anyway. So if the probability you have an urn containing 3 red balls, 4 green balls, and 5 yellow balls, 12 balls, what is the probability of the red ball drawing on a single? So 12 balls altogether. So 3 out of 12, you'll notice is equal to 1 out of 4. So that's the probability there. Okay. If the odds of the Broncos beating the Dolphins is 5 to 4, and you bet $10 on the Broncos, what do you stand to win? Okay, well, you had a probability of winning in the first case, so if you bet the favorite, you don't get equal to or more than the $10 that you bet. You would get, in this case, 4/5, so that would be $8. Okay, that's what you would win if you bet 10. You're gonna bet $10 in order to win 8, since you're betting the favorite in this case. 9, given an urn containing 4 red balls, 3 green balls, and 5 yellow balls, what are the odds of drawing a red ball on a single draw? All right, well, the red balls represent 4 out of 7, 12 balls. So you have there, in this case, you have 4 to 8, or 1 to 2. 1 to 2. Well, why is that? Because there are 4 favorable outcomes. Okay, F4. Unfavorable outcomes would be, it should have been 8, so since there are 12 balls altogether, unfavorable outcomes would be U, so 4 out of 8 or 1 out of 2. These formulas are given, you'll notice, earlier in the chapter. Okay, and that's all you need to do for here, okay? So I just wanted to get you started with these. Oh, by the way, we can do number 10, I suppose. Suppose you're given 1 to 6 odds that you'll roll a 1 with a single fair die. If someone accepts your bet, how much would you expect to win after 100 rolls if you bet $1 on each roll? Well, 1 out of 6 times $1 is $16.67. So if you multiply that times 100, since you're going to have 100 rolls, that would be about $17, actually $16.67. So not a bet you should take, obviously. Okay, so that gets you started with probabilities. I just wanted to give you a little bit today. We'll do more. I hope you'll stay well until we see each other again. Thank you.